Welcome to Unit 4. In Unit 4, we are studying exponential functions and equations. So I will read the overview at the top of your unit plan. In this unit, we will build on our knowledge of exponential functions. Recall from Unit 1, we compared exponential functions to geometric sequences because both grew in the same way. Do you remember how they were similar to each other? So they are similar because they were multiplying by a constant every time. We will practice representing exponential functions multiple ways, using tables, coordinates, graphs, equations, and we will explore some real-world applications of exponential functions related to growth and decay, especially half-life of an element. In the second half of the unit, we will explore log functions and how they can be used to solve exponential equations. So my first question is, do you know how to solve for x in this equation? 2 to the x equals 8. Okay, so we know that 2 to the third power is 8. So in the first equation, x would have to be 3 to make it true. And do we know how to solve for x in the second equation? Well, we know that 2 to the fourth power is 16. So in the second equation, x would have to be 4. So the big question is, how can we solve something 2 to what power would give me 10? So 10 falls in between 8 and 16, so we can assume it's somewhere around 3 point some number, maybe 3.2 or 3.3. So is there a way that we can do this other than estimating? So on your calculator, I wonder how close you can actually get. So if I do 2 raised to maybe the 3.2 power, that gives me 9.18. How about 2 raised to the 3.4 power? 10.55, so I guess 2 raised to the 3.3 power, is that the closest we can get? So somewhere right in that range, but we don't have an exact answer. Somewhere between 3.2 and 3.4 is our answer for x, because it gives us an output around 10. So this unit, we're gonna figure out how do we actually solve that equation. And if you look at our layout for the units, we are looking at a quiz on Tuesday the 19th, and we're looking for ending the unit kind of a full week after we're back, around the 9th. I also put on the back page of your unit plan, what are we doing at the end of the semester? So kind of looking ahead, we're gonna do kind of a 3-day overview of some things in Unit 5. We'll have 2 final exam review days and then our final exam, and then our year is over. Okay, so you are going to open your new textbook to page 383, 4.1, and our goal for the day is just let's calculate exponential change and review some things about exponential functions. So the warm-up question is, if a bank account has a balance of $120 on January 1st, describe a situation in which the account balance for each month forms this following type of sequence. Write the first 3 terms of each sequence. So they want you to describe an arithmetic sequence and a geometric sequence. I'm going to give you an example of each one, and I want you to come up with your own example in your workbook. So an example of an arithmetic sequence would be maybe adding $10 every single month. Adding $100 every single month. So for example, if I started out with 120 and I added $10, then I would have $130. And then I would have $140 and then $150. Or if I started with $120 and I added 100, then I would be at 220, 320, 420. So maybe you remember that this is arithmetic, right? We're adding a common difference every single time. Okay, geometric sequence. Do you remember what a geometric sequence is? It's very important for this unit. It's very similar to an exponential function. So if I start with 120, I could multiply 120 by a constant. Double my money, triple my money. Maybe I only have 1.5 of my money. So let's say that I double my money. Then I would have $240. So I want you to write down what you would have the next couple months, maybe if you were doubling your money. Or if you were tripling your money, it would go from 120 to 360, and then you'd have to multiply times 3. This one was multiplying times 2. So we're going to do some review about sequences in this unit on exponential functions. So complete that problem and turn the page. So before we do this activity, I want you to think about a place that you would like to go where you need a passport. And my trip where I would like to go is Ireland. And I'm hoping to go there in 10 years as a graduation trip when my son graduates high school. So I want you to write at the top of this page a place that you would like to travel. And we are going to try this problem together. So it says the distance from Elena's chin to the top of her head is 150 millimeters in an image. For a U.S. passport photo, this measurement needs to be between 25 and 35 millimeters. So I want you to label the passport photo picture. So it is currently, it says from her chin to the top of her head is currently, right, from here to here, 150 millimeters. And she needs to scale her photo so that it's between 25 and 35 millimeters. The first question says, find the height of the image after it has been scaled by 80%. How can we represent 80% as a decimal? So multiplying by a ratio of 0.8 is 80%. So they want to know if you take 80% and multiply that by the 150 3 times, what would be the new height of the image? So we're going to take 150 times 0.8 times 0.8 times 0.8, or a shortcut way would be 0.8 to the third power. So why don't you find what that is on your calculator, and then you are going to complete the second part right here on your own. So 150 times 0.8 to the third power, I got 76.8 millimeters. So I now want you to try the 6 times on your own. So I'll be looking for that question to be completed. So now this asks you, how many times would the image need to be scaled by 80% for the image to be less than 35 millimeters? So if you notice, 3 times is not enough, right? They want to know how many times. Is it 3 times, 6 times, 7 times, 8 times? How many times to be lower than 35? And how many times would you have to scale it to be less than 25? So I want you to work on these 2 questions with your partner and see if you can figure it out. All right, once you have finished activity 1.2, you're going to go to page 385, Pond in a Park. On May 12th, a fast-growing species of algae is accidentally introduced to a pond in an urban park. The area of the pond that the algae covers doubles each day. If not controlled, the algae will cover the entire surface of the pond, depriving the fish in the pond oxygen. At the rate it is growing, this will happen on May 24th. So on which day is the pond halfway covered? So if you're thinking about this pond, right? So here's my pond. I'm going to do it as a circle just because I think about that better. So if it's fully covered, the whole thing, on May 24th, and it's doubling each day, when is it halfway covered is the question. Well, if you double it, isn't it going to cover the full area the day after it doubles in size? So it must be halfway covered the day before, right? May 23rd, it was halfway covered. And then if you double this area, now you've covered the whole pond. So now this says, on May 18th, Claire visits the park. A park caretaker mentions to her the pond will be completely covered in less than a week. Claire thinks the caregiver must be mistaken. Why might she find the caretaker's claim hard to believe? So I want you to think about how much of the pond do you think was maybe covered on May 18th? Maybe you could make a table to help you figure this out. So here's how maybe you could say the date, and you could say maybe the percent covered. All right, so we know that on May 24th, what percent of it was covered? 100%, right? On day 23, we said 50% or 1/2 of the pond is covered. So if you work backwards, 22, 21, 20, day 19, maybe you could think about what percent of the pond was even covered on day 19. What would that look like? Would it look like anything? Could you see the algae? And maybe that is what you could use to justify why her claim is hard to believe. So I'll be looking that you kind of completed this table and wrote a reason why the caretaker's claim was hard to believe. So then number 3 skips to what fraction of the area was covered by algae on May 12th. So they're using fractions in question number 3. So in our table up here, if we're cutting this number in half, right, we're doubling it in this direction, we're cutting it half as we work backwards. So I would have 25% covered. 25% is the number 1/4. How did I know what fraction that was? I took 25 and divided by 100 on my calculator for 25%. Oops. So if I do 25 divided by 100, it gives me 0.25 as a decimal. If I want to turn that into a fraction, if I hit math fraction enter, it'll tell me the fraction is 1/4. Let's do one more. What's half of the number 25? If you're not sure, 25 divided by 2 is 12.5. So I had 12.5% covered. So let's see, what is 12.5%? So divide by 100. What is that written as a fraction? 1/8. So maybe you can see a pattern in your fractions as they go backwards. Maybe look at the denominators. But question 3 is asking you what fraction of the area was covered by algae initially on May 12th. Explain or show your reasoning, and I'm kind of directing you to show your reasoning using a table of values. So now that you have completed up through page 385, we will do the lesson synthesis and learning targets together next class. You are going to work on completing the practice problems on page 387 to 388. And if you notice, a lot of this is about sequences, right? Selecting sequences that could be geometric, which means which ones are multiplying to get to the next number. So let's see, this is a sequence again, a sequence. So there's a lot of review on sequences. If you are unsure about how to answer those questions, I have posted the Britta Dwyer video on Google Classroom in the unit plan so that you can access that. So up through page 388 needs to be finished. And if you have extra time, you are welcome to do a coloring contest page for a bonus point on your unit test from yesterday. Thanks.